Hi students, today we will discuss a very interesting question from strictly increasing and decreasing functions. Now coming to the question, find the least value of a such that the function f of x equal to x square plus ax plus 1 is strictly increasing on the interval open interval 1 comma 2. Now coming to the given function f of x equals to x square plus ax plus 1. If you observe this given function, it is a quadratic expression, right? So that quadratic expression and the coefficient of x square clearly here is 1, which is greater than 0. In case of that coefficient of x square is greater than 0, that quadratic expression will be upper curve and it is having a minimum value and the maximum value is not defined, right? And to get strictly increasing or strictly decreasing, we need to do the differentiation, so that differentiate with respect to x on both sides, so that f dash of x equals to 2x plus a. So this is what a linear expression, so that it represents line. Now move on to the given function f of x equal to x square plus ax plus 1. The coefficient of x square is greater than 0, so that f has minimum value and the maximum value is not defined. Because of that f has minimum value, the curve will be like upper parabola, and if you observe the rough diagram, the graph will be like this. Now they has mentioned clearly this function is strictly increasing on the interval open interval 1 comma 2. So just if I say that it is in between 1 comma 2, the function is strictly increasing in between 1 comma 2. Now if you observe the originality of the graph, which means here it is 1 and it is 2. Now if you observe the originality, at 2 the function is strictly increasing. In between 1 and 2 also the function is strictly increasing, and after 2, by seeing this diagram, after 2 also the function is strictly increasing, right? So which means what? It is very clear that f dash of 2 is also greater than 0, right? So f dash of x here is 2x plus a, so that f dash of 2 means 4 plus a greater than 0, which means a is greater than minus 4. This is the one case of this given condition. Now move on to the very important condition in this is here given clearly that it is strictly increasing in between 1 and 2. So at 1 there will be a two possibilities for this curve. If you observe the graph, there will be two possibilities. The first one is, because of the mention in between 1 to 2 it is strictly increasing, at 1 maybe the function has a turning point, will be like this, it is a turning point. Or because of it is increasing in between 1 and 2, at 1 also the function is strictly increasing. This is the another condition. But we can't say that the function is like, if it is like this, if 1 is here and 2 is here, then we can't say that function is strictly increasing in between 1 and 2. So it is very clear that f dash of 1 is less than 0 is meaningless. So f dash of 1 is not less than 0, right? So there will be two possibilities according to the diagram. The one main very important point is f dash of 1 equal to 0, because of it is a turning point, or f dash of 1 greater than 0. In those two conditions, we can write like f dash of 1 is very clear that either greater than 0 or equal to 0. Those two are only possible conditions. So that f dash of x is 2x plus a, so that I can say it is a plus 2 greater than or equal to 0, so that a greater than or equal to minus 2. So we want least value of a, so that the least value of a is minus 2. And if you observe here, from the one condition it is a is greater than minus 4, from the another condition a is greater than or equal to minus 2, so that a greater than minus 4 and a greater than or equal to minus 2, by combining these two, this intersection of these two will become a greater than or equal to minus 2. So that this is the condition we have to consider finally. So that least value of a is what? Minus 2. Thank you.